Hi everyone. Today the set that we are going to discuss is again a set from a previous year CAT paper. It's from CAT 2005. It's a very interesting set on Venn diagrams. Let's get on with it. Help Distress is an NGO involved in providing assistance to people suffering from natural disasters. Currently, it has 37 volunteers. They are involved in three projects: tsunami relief in Tamil Nadu, flood relief in Maharashtra, and earthquake relief in Gujarat. Each volunteer working with Help Distress has to be involved in at least one relief work project. Now, the moment you read this sentence, has to be involved in at least one relief work project, immediately you should start thinking that a person can be involved in more than one project, which means a person can be involved in tsunami relief alone, or in flood relief alone, or in earthquake relief alone, or in a combination of tsunami relief and flood relief, and so on. The best possible way to represent all these intersections in one chart would be Venn diagrams, and therefore the language of the first paragraph itself tells me that I should start with making a Venn diagram. Now I have three sets: people who are involved in tsunami relief, people who are involved in flood relief, and those who are involved in earthquake relief. I'll start with a Venn diagram with three sets. Now at this point, the first thing that I feel like is reading up all the information wherein numbers are given so that I can straight away plug those numbers somewhere. Now, the first point does not have any numbers, so I'm not going to go with that. The first point of interest that I feel is the third one. 17 volunteers are involved in the TR project. 17 people are involved in the TR project. That means those who are involved in TR alone, those who are involved in TR and ER alone, those who are involved in TR and FR alone, those who are involved in all the three projects. The sum of all these values should be 17. Next data point that I get is 10 volunteers involved in the TR project are also involved in at least one more project. Coincidentally, this point also talks about the TR project, of which I already know a certain number. 17 people are involved in the TR project in all, out of which 10 are involved in at least one more project. That means they are not involved in only TR. They are either involved in TR and FR, or TR and ER, or all the three. So there are 10 people in these three areas, which means that there must be 7 people here. Very straightforward. Now, also I recall each volunteer working with Help Distress has to be involved in at least one relief work project. So there is nobody who's not involved in any projects. So this must be 0. Fair enough. Going forward, I know that the sum of all the numbers in this set is 17. So out of 37 people, 17 people are inside the green circle. That means the remaining 3 values should add up to 20. Now I have a lot of information to work with. Let's go ahead. The number of volunteers involved in the TR project alone is 1 less than the number of volunteers involved in ER project alone. It's talking about TR project alone and ER project alone, and it says the number of volunteers in TR alone is 1 less than number of volunteers in ER alone, which means the number of volunteers in ER should be 8. Now, the number of volunteers involved in ER project alone is double the number of volunteers involved in all the three projects. ER project alone is 8. This is double of those who are involved in all the three projects, which means this value, that is 4. Now I already knew that the sum of these three areas should be 10. If this is 4, then the sum of these two areas should be 6, which means if I take this value as A, then this must be 6 minus A. Now, for 6 minus A to be a whole number, A should be less than or equal to 6, which is one condition that we know about A at this point. Fair enough. Now the first point, a maximum number of volunteers are involved in the FR project. Maximum number of volunteers are involved in the FR project. Among them, the number of volunteers involved in FR alone is equal to the number of volunteers having additional involvement in the ER project. So that means this value FR alone is equal to this area. So if I were to say that this is B, then the number of people who have additional involvement in ER is 4 plus B. So that should be equal to FR alone. So I can write an equation here saying that B plus 4 plus B is equal to 12. How do I get that? I know that the sum of these three areas should have been 20, out of which this is 8. So the sum of the remaining two areas must have been 12, and therefore B plus 4 plus B is equal to 12 is an equation that I am going to write down. B is equal to 4. So I just take out all these values and I put it back in this. At this point, I can quickly total up all the values in the FR project and all the values in the ER project. So 8 plus 4, 12 plus 4, 16 and 6, 22 minus A is the number of people involved in the FR project. We already know that there are 17 people in the TR project, and in the ER project 8 plus 4 plus 4, 16 plus A. Number of people involved in the ER project is 16 plus A. But I also know that the number of people involved in the FR project is the maximum, which means 22 minus A should be greater than 16 plus A. So A was supposed to be less than or equal to 6. Now I also know that A should be less than 3, which means in effect A should be less than 3. What all values of A could be possible then? A must be one among 0, 1 or 2. So keeping that in mind, I'll just quickly redraft this solution. TR, FR, ER 0, 17, 7, 8, 4, A 6 minus A, 8, 4, 22 minus A, 16 plus A. This was supposed to be maximum. A should be greater than 0, A should be less than 6, and 22 minus A should be greater than 16 plus A. Hence we got that A should lie between 0 and 2. That means A can be 0, 1 or 2. I hope this Venn diagram is clear to all of us. Now let's go ahead and take a look at the individual questions. First one, based on the information given above, the minimum number of volunteers in both FR and TR projects but not in the ER project is. So we are talking about the minimum number of people who are involved in both FR and TR but not involved in ER. That means we want to minimize 6 minus A. Now, if I want to minimize 6 minus A, then A must be as large as possible. So, the largest possible value of A is 2. We know that already. So, 6 minus 2 can be a minimum of 4. The correct answer is answer option 3, which is 4. Next question. Which of the following additional information would enable us to find the exact number of volunteers involved in various projects? What is the only thing that we are missing right now? These two values. At this point, if I get to know A, I can find out all values. So all I need is a piece of information which will help me find A. Let's take a look at the first statement. 20 volunteers are involved in FR. If I get to know that 22 minus A is equal to 20, can I find out the value of A? Yes. What will it be? 2. So yes, this will help us find everything. Because no option has more than one of the above or all of the above is given at this point, I can conveniently mark my answer as 1. But let me also just show you that the remaining two pieces of information are not really handy. 4 volunteers are involved in all the 3 projects. Big news. We already know that, isn't it? 23 volunteers are involved in exactly one project. Again, great news. We already know that 8 plus 8 plus 7, 23 volunteers are involved in exactly one project. Both of these pieces of information we already knew. So, answer option 1 is the correct answer. Next question. After some time, The volunteers who were involved in all the three projects were asked to withdraw from one project. Okay, now there's some additional thing happening here. Let's take a look. The volunteers involved in all the three projects were asked to withdraw from one project. So we are talking about these people here. They are supposed to withdraw from one project. So if a person is already working on three projects and withdraws from one project, he'll still be involved in two projects. As a result, one of the volunteers opted out of TR. So the one who opts out of TR will still be involved in FR and ER. So he'll come out to be at this point. So one person goes from here to here. One opted out of the ER project. So the one who opted out of ER project will go from here to here. While the remaining ones, how many people are remaining out of 4? If 2 have gone, 2 are remaining. Remaining ones involved in all the three projects opted out of the FR project. So they must have gone here, 2 people. So what are the new values of these three places? Let's just quickly jot them down. For the sake of clarity, I have put them in boxes. Now that that's done, let's take a look at the question. Which of the following statements then necessarily follows? Okay. The lowest number of volunteers is now in TR project. Well, I'll have to check that. How many people withdrew from the TR project? 1. So the number of people who withdrew from the TR project was 1. That means the new total is 16. Likewise, one person withdrew from ER. So the new total must be, and likewise 2 people withdrew from FR. So the new total should be. Now, the question remains, is it necessary that the lowest number of volunteers is in TR? So 20 minus A, can this be less than 16? For that, A should be greater than 4. That's not possible. We already know that A must be 0, 1 or 2. What about 15 plus A? Can 15 plus A be less than 16? For A to be less than 1, A can still be 0. And 0 is an allowed value for A. So yeah, it's possible that ER can have the lowest, which means that it is not necessarily true that TR has the lowest. Therefore, this statement does not necessarily follow. Revise what I did here once before I analyze the next statement. More volunteers are now in FR project as compared to ER project. So the statement says that 20 minus A is necessarily greater than 15 plus A. Let's check. Well, that's true. A will always be less than 2.5 because the maximum permissible value of A is 2. So in any case, this will be true. It seems like the second option is necessarily true. However, to be confident about it, let's also evaluate the third statement. More volunteers are now in TR project as compared to ER project. Is the value of TR necessarily greater than the value of ER? No, we've already seen that, but just to show. Well, it may be, may not be, and that's why we can clearly say that the third statement is not necessarily true, which means the answer is second statement. Let's take a look at the last question now. After the withdrawal of volunteers, as indicated in question 3, some new volunteers joined the NGO. So we are already supposed to take into consideration what was given in the previous question. So let's do that. Some new volunteers joined the NGO. Fair enough, some new volunteers are going to join. Each one of them was allotted only one project in a manner such that the number of volunteers working in one project alone for each of the three projects became identical. So new people are going to come in. If X people come in here, then X people must also come in here for the total number of people working in FR alone and ER alone being the same. But for the number of people working in TR alone to also become the same, the number of people that join here should be x plus 1. So the new people joining should be 3x plus 1. At that point, it was also found that the number of volunteers involved in FR and ER projects was the same as the number of volunteers involved in TR and ER projects. FR and ER projects was the same as TR and ER projects. Now I hope you recall that this value should be 0 because already all the people here should have left. Okay. So essentially there are 5 people here and there are A plus 2 people here which should be equal. Well, for that to happen, A should be equal to 3. But we already know that A cannot be equal to 3 based on the previous conditions given in the set, which means something is wrong. Either this new data is wrong or the previous information in the set was wrong. One of these must be wrong, which means that the data is inconsistent. I hope you thoroughly understood each question in this set. It's a very interesting set and a very basic set on Venn diagrams. Thank you all very much.